How does the Oort cloud stay attached to the solar system as it moves through space? How can you generate power using a black hole? And what should you do if a meteorite falls into your yard? And in Q&A Plus, which upcoming NASA missions are worth advocating for? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are, across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. INVISIGOTH, if a 10-pound meteorite landed in your yard, would you keep it, sell it, or give it away? I would contact scientists. So I would, and I'm specially equipped to be able to make contact with the scientific community. I would reach out to planetary scientists and say, a 10-pound meteorite just landed in my yard. It's fresh. What would you like done with it? And probably it is put it in a bag and stick it in your freezer right away. Whenever there are fresh meteorite falls, they're very exciting and very useful. They're very scientifically interesting because these things have been out in space, possibly since the very beginning of the solar system. They've been orbiting around and around, and they have just entered the Earth's atmosphere for the first time and landed on the ground. And so they're still fresh from space, and they haven't been colonized by Earth bacteria yet. They haven't been weathered down. They haven't had some of their minerals replaced with things on the surface of the Earth. And so whenever there is a meteorite that has a chance of surviving to the surface, then scientists will do big surveys to try and find them. There was one that landed here in Canada. It happened in the wintertime, and people calculated that it was going to hit a lake. And so they were able to go out and get it while it was completely cold out. They were able to pull it out of the ice, and they were able to put it into cold storage. So that's what I would do. I would quickly take it, stick it in the freezer, and then I would contact planetary scientists and let them know what I've got. Ravens Moreland. If a spaceship launched with a balloon that was a meter bigger than the ship, could it collect water from the plumes of Enceladus to freeze around your ship for radiation protection? I don't know. I mean, I don't think you could collect enough water from Enceladus to be able to actually form a shell around your spacecraft. But water is a great idea. Like, if you can get your hands on water and form it in a shell around your spacecraft, then you will be protected from space radiation. Though you just need a meter of water in a bubble around your spaceship. If you have that, then you're protected from the radiation. But I don't know whether trying to collect it coming out of Enceladus is going to be the right way to do it. You're going to want to sort of launch with your water. And what's great about water is you need it for other things. It's for drinking. You can use it for breathing, break it up into hydrogen and oxygen, use it for fuel. It's a lot of good reasons to keep water with you. It's also very heavy. So it uses a lot of propulsion to try and accelerate water. But once you, say, have a base on a world, you can totally form water into a shell above you. It's transparent, right? It's like a window, and it's protecting you from radiation. 1,000 dots. If someone made organic von Neumann probes, would we just mistake that for panspermia? So the idea of von Neumann probes, these are self-replicating robot probes that go from star system to star system. Panspermia is this idea that life spreads from world to world within the star system through asteroid impacts. So is bacteria an organic von Neumann probe already that nobody made? Like, it just is happening, right? That, if you take bacteria and you hit it on Earth with an asteroid, it can fly to space and survive, and then it can handle being in interplanetary space for a few centuries, and then it crashes back down onto the surface of some other world, and then it can survive that, and then it can go on to propagate. So, nobody had to design it. It just already has the capability to do that. And that you could then extend that idea that, if the Earth is shedding life, and when Gliese 740 comes within 0.22 light years of us, maybe some of that life will reach Gliese and spread. And then maybe that's how life spreads from star system to star system. It could be that we eventually 1,000 years from now, we get to a nearby star system and we find there's life there, and we find that it has a common ancestor that we do, and that we can actually trace that there was another planet where life came from before life got to the Earth and Alpha Centauri. So, there's lots of, like, we report on papers from time to time where people propose different ways, different methods of interstellar panspermia. So that idea working within the solar system could very much work from star to star. You know, you have to explain how life can survive hibernating inside a comet for 10 million years. But, you know, if that's possible, or if there's like water inside the comet and it stays liquid and life can stay alive for a while, you know, who knows what's possible. Jani A, what is your daily routine gathering information and keeping yourself up to date in science? Are there certain magazines, forums, subscriptions, or contacts that you find reliable? Do you have a team collecting the information? So the way Universe Today works is that I am the main person for finding the stories that we're reporting about. And this is a task that I've been doing for 26 years. Which is that I go through all of my sources every day. And then if I find anything that I think is something that we should be reporting on, then I will pass it along to the team. And I have a ton of sources. I think I've got about 1,000 places that I can potentially look. Now, they don't all update every day, and so it's some subset. I use an RSS reader. I use Feedly to sort of gather all of the sources together. And what Feedly does that's really nice for me is that it lets me turn web pages into feeds so that I can check for any updates on them. And so I have feeds for, all of the space agencies, all of the journals, all of the universities that have significant space science research, all of the conferences that are going on, all of my competitors, everyone else who's reporting on space news, Reddit, Twitter, Blue Sky, all of the sort of places where people are talking about space, forums, as you said, newspapers. And so that's sort of the process that I go through every day. It takes me about an hour or so to just go through and evaluate all of the stuff that's breaking for the day and to put that into a form that then the writers can write from. And then it makes their job very easy. The writers are able to write whatever they want, whenever they want. It's up to them. But it sure is handy if Fraser has put a bunch of stories that are really compelling into this bucket, and all they have to do is just go in and grab a story out of that bucket. And I have a certain perspective that I'm really interested in. And so the stories on Universe Today, because I'm sort of the one who's found the news in the first place, they very much reflect my personality, for good or for bad. So the kinds of stories that we're reporting on. And then that process, that thing that I do every day, then becomes the beginning of the rest of the reporting that we do. So when I'm seeing these interesting stories, if one feels like it's going to make a good interview, I will, in addition to handing the story off to a writer, I will reach out to the researcher and say, can I interview you on the YouTube channel? I will write up my description of the story, and then that gets turned into the newsletter at the end of the week. And then also all of the stuff that we do on Space Bites comes from all of the stories that we're reporting on Universe Today. So we've been doing this so long and very efficiently at this point that it's sort of this holistic soup to nuts process. But it starts with me sitting down every single day for about an hour and just getting a sense of the lay of the land. What's all the stuff that's happening? What's the chatter? And then from that, we continue our reporting for the week. It's time to shout out our new patrons at the $5 level and above. Jay Freun, Rebecca, Justin M, The Real Retro Game Brews, George Koch, Gary S, Patty, Luis Sanbria, William Mirowitz, and Graham. Join our community at patreon.com/universetoday. Johnny, if the solar system is moving fast through space and the gravity of the sun is pulling rather than pushing away, how is the Oort cloud even a sphere? Why doesn't everything ahead of the motion get overtaken? It's all moving with us, right? The sun is moving through the Milky Way. The planets are orbiting around the sun as the sun is going through the Milky Way. The Oort cloud is this cloud of comets that is moving with the sun around the Milky Way. It's all tied together. So it's not like, if the Oort cloud was separate from the sun and they, then they would come apart. But because it's all just moving together, it's like, you're on a boat and the boat is moving through the ocean. Like, why don't you just fly off the back of the boat? Well, because in this case, the friction of your feet touching the boat and you are moving at the same velocity. And so you're not falling off the back of the boat. Think about when you're in an airplane, right? Why don't you fly out the back of the airplane? Because you are sitting in a seat, you are moving the same speed as the airplane through the air, and your motion is tied with it together. Damian Reloaded. If the universe is infinite, does that mean that the Big Bang contained infinite matter? Sounds fishy. So the important thing to understand is that the Big Bang is a process where the universe is becoming less dense over time. That right now, when we look out into the universe, we see galaxies moving away from us. The universe is becoming less dense. And if you sort of look back in time, then those galaxies were closer together. And eventually those galaxies were right on top of each other, that they were all in the same area. If the universe is infinite today, the universe was infinite before the Big Bang, before this process of rapid expansion and decreasing density. There wasn't this point where you had an infinite amount of universe packed into a finite little ball. So instead, like you have to think either in terms of the observable universe or the entire universe. So when we think about it in terms of the observable universe, right? You look out in all directions, you see this giant sphere, and that's the stuff that the light has been able to travel to your eyeballs. That is what you can observe. And at the very beginning of the universe, what is now a sphere 93 billion light years across was once the size of a grapefruit, or was once the size of something even small, a marble, very small. And then it became less dense over time. But right beside that grapefruit of our observable universe, or more specifically, my observable universe, which is different from your observable universe, there was another one right beside it. And that was somebody else's observable universe. And that is now a 93 billion light year across sphere containing all of the material that light has been able to reach this person's eyeballs. And there's an overlapping, right? Our observable universes can overlap a bit. So it's not that the entire infinite universe was compressed into a small space. It was still infinite. Even before this process of becoming less dense over time, whatever set the Big Bang in motion, there was still an infinite universe beforehand, and then an infinite universe afterwards. So don't think that you had to go somehow compress infinity into a finite space. Owen Bowen. How can a black hole be used to generate power? So there are a couple of ways that black holes are theorized that they can use power. The first way is that you feed material to the black hole. Most of the material will go into the black hole, but you will also get high energy radiation coming off the black hole. You get gamma radiation. So theoretically, if you put like a mini Dyson sphere around your black hole, you will be able to capture the energy that is coming off the black hole. And really, it's just like as matter is falling into the black hole, as matter is going into an accretion disk around the black hole, there's lots of ways that black holes can release high energy radiation, X-ray radiation, gamma radiation, and so you could theoretically harness that. But the most efficient way to harness power or energy from the black hole is known as the Penrose process. And this was a clever idea thought up by Penrose, where you drop material into the black hole, and then the material will some of it will go in and some of it will be kicked out. So say you drop a, cannonball into a black hole, and just as the cannonball is about to go into the black hole, you hit it at just the right angle. Then part of it goes in and part of it then gets a kick, almost like a slingshot, back out. And then you can capture the kinetic energy of this material that wasn't consumed by the black hole. And then you can use that to power your starships or whatever. And I forget the exact number. I think it's 38% efficient. So the most efficient process you can get to get energy is matter and antimatter. So if you have matter, you have antimatter, you put them together, it is 100% efficiency. You can gather all of the stored, E equals mc squared between the matter and the antimatter as you put it together. With the Penrose process, it's 38% efficient. So it is extremely efficient compared to almost every other form of energy that we possibly know of. And there's like a third way, and I forget what it is. Maybe do a follow on of what, because there was like a paper that came out a year ago, 2 years ago, that we reported on, and somebody had come up with a novel additional way that you could harness the energy from a black hole. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. In this week's bonus question, which upcoming NASA missions are worth advocating for? And I'll put a link in the show notes. You can go watch that right now. All right. Those are all the questions that we had for this episode. Thank you everyone who put your questions into the YouTube comments, as well as everybody who joined me for the live show, which we record every Monday at a rotating time. Now, the next episode, if you're watching this sort of during the week that I released it, is going to be 8 a.m. Pacific time. So that's the one that is designed for the Europeans to be able to watch the live question show during their evening. You're welcome, Europe. Now, I'm going to talk about the 10 science fiction shows that were most influential to me. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nielsen, David Varibaff, David Giltonen, David Matz, Evan Pro, Greg Feely, Hudson Moore, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Sitz, Michael Purcell, Modzo, OneStepForAnimals.org, Paul Robach, Rinkaidu, Richard Williams, Sean Sargent, Stephen Fowler-Munley, Team 49, Telescopes Canada, Vlad Chiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. Now, I watch a lot of TV and movies, and, people are always asking me for my recommendations for good sci-fi television shows, movies, and I've got this sort of ever-evolving list of the stuff that I consider to be the most influential to me. And so if I had to winnow down all of television to just 10 science fiction shows, here's my list. So first up is Andor, which I won't shut up about, which is, of course, the Star Wars series, the prequel to Rogue One. Such a good TV show. It's probably my number one. Then influential would be Avatar: The Last Airbender, which is the cartoon that came out on Nickelodeon decades ago. It's sort of like one that we raised our kids on. And so it has a very special place in my heart. Next is Cowboy Bebop, which was sort of one of the first anime that I got into back in the 90s. And it's just such a good story, total sci-fi. And if you watch Firefly, you'd be like, okay, now I see where Firefly got some inspiration from. Next is something many of you probably haven't seen. It's called Devs. And it's a TV show that was written and produced by Alex Garland, who is the same person who did Ex Machina, wrote 28 Days Later, Civil War. He's one of my favorite directors / writers, and this is such a good show. And the next comes what I think is my favorite one, and that is Love, Death, and Robots. Like if I had to winnow my entire collection down to one thing, it would be Love, Death, and Robots, which is a series of short animations on Netflix. They've got 4 seasons, and they're so good. Next would be For All Mankind, which is a series on Apple TV, and it just tells this alternate history of what would happen if the Soviets were the ones to land on the moon first, and we would have an ongoing space race. Next is a show that I don't think many of you have seen called Scavenger's Reign, and this was recommended to me over and over again by some very persistent people on the channel, and I finally got around to watching it. It is so good. It is this weird animation about these people who are crash landed on this alien planet, and the way the life works on that planet is really bizarre, but so interesting. Next is Star Trek: The Next Generation, and it's not necessarily as good as the other shows that I really like, but it's like such a classic, something that I really got into for science fiction back just after I graduated from high school. And so it just has a special place in my heart. But a even more special place in my heart is Stargate SG-1. And in fact, my wife and I are rewatching the whole series, and it totally stands up. So an alternative to Star Trek is Stargate, and I really enjoyed the series. And then last but not least is The Expanse, which is the recreation of the sci-fi book series, but it is just such a great television show, hard sci-fi in many ways and just really well told. And so like that probably battles Love, Death and Robots as my top spot. All right, that was my list of top 10 TV shows, most influential shows for me. Next episode, I'm going to give you my movies.